this lesson is on piecewise functions, and number one is an example of a piecewise function. You'll notice it looks a little different. It has a couple of different or maybe several different equations, and they're only used for certain parts of the domain. So what we're going to be talking about is how to find different values and then how to graph those. So what you need to think about is this is going to be the graph of x plus 2 for x values that are less than 1. It's going to be the graph of x minus 1 squared for values that are greater than or equal to 1. Now, when you're given problems like you see here, f of negative 2, f of 0, and f of 1, you have to plug it into only one of those equations, the one that it applies to. So since the negative 2 is something that is less than 1, that would fall in this category. That means I plug it into that top equation, x plus 2. So I plug in and get negative 2 plus 2, and so I get a 0 out. That would be my answer. Now for part B, I have f of 0. 0 is also less than 1. And so it also falls into that top category, and so I use the top equation. So 0 plus 2 gives me 2. Then I come down to C, f of 1. Well, which one does that fit into? That fits into the one where it is equal to 1. And so I'm now plugging into the bottom equation. So I would plug in 1 minus 1 squared, which would be 0 squared, and I would get 0. And then f of 3. If I plugged in 3, 3 minus 1 is 2, and 2 squared is 4. Okay. Now, when you plug those in, sometimes they just ask you to do that. When you plug those in, you're actually finding points on the graph. Okay, so negative 2, 0 is a point on the graph, 0, 2 is a point on the graph. And we're getting ready to graph this, so we can refer to those as well. Now we're going to sketch this graph, and the first part is x plus 2 for x is less than 1. Before I start graphing those, I like to highlight the parts of the domain that I'm using. And because the first part is x is less than 1, I'm going to highlight all this over here that would be area where x's are less than 1. So this side of my graph from positive 1 back to the left is where I'm going to put that graph. X's are greater than 1 or equal to 1 from 1 on. So I'm going to highlight this over here for what I'm doing. And so I've divided this up because I'm going to graph the first thing just in the yellow and the second thing just in the blue. I only want that section of the graph. Okay, now that first section is supposed to look like the graph of x plus 2, and the second section is supposed to look like the graph of x minus 1 squared. So x plus 2 is a line with a y-intercept of 2 and a slope of 1, or you can think of it as your toolbox function y equals x moved up 2. But you know that the y-intercept is going to be 2 either way. And if the slope is 1, you're going up 1 and over 1. And you can kind of see how the line would be working. The only thing that you need to make sure to notice is that for this graph, it was for x's less than 1. And that less than means I need an open circle on the 1. So I'm going to put an open circle right there where it would cross where x equals 1. And I'm going to draw the rest of the graph in. I'm only looking at that line that falls in the yellow. I mean, if I were graphing that for real, yes, it would continue on over here. But because I'm doing a piecewise, I only want the section of that line falling in the yellow. Okay, the second part, this x minus 1 squared, is your parabola moved right 1. So my normal parabola goes through 0, 0. If I move it right 1, it's going to go through 1, 0, and that'll be like the bottom, the minimum of it. But I only want the part of it that's going to be in the blue. And if the minimum is right here, I only want this part that's this part of the parabola, because it's the part that's in the blue. If I were graphing the whole thing, yes, I would see the part that curved up over here. Now this part had x greater than or equal to 1, which means on 1 I need to put a closed circle because of that equal to. So I put a closed circle here. You'll notice that this will pass the vertical line test now, because I can pass a vertical line over all this and it's okay. I can pass a vertical line over all this and it's okay. And then where x equals 1, I just have one of those filled in. It's not hitting both at the same time because this one up here is an open circle. And that is what the graph looks like. As we move to example 2, you may want to pause and try to do A, B, and C on your own. This would be a good time. Okay, for part A, -3 is less than -1, so that falls in the top part. And there's no x there, which means the answer is -3 for everything that you plug in there. F of -1, that would fall equal to here, this -1. So again, I'm going to get a -3. There's nothing to plug in or simplify in those cases. When I get to f of 2, 2 is greater than -1, so I actually have a formula to plug into. So I'm going to plug in -2 squared plus 4. That'll be a -4 plus a +4, which gives me a 0 for that one. Now as we move to sketch the graph, the first thing I want to do is highlight the sections that I want to be in. And according to our function, we are having one thing happening before -1 and one thing happening after -1. So these are going to meet at -1. So I'm going to find -1 and I'm going to do everything to the left of it in one color. And everything to the right of it in another color. And this part isn't perfect. It's just to make me think in the right way, to think about my graph as only being over here and only being over here. Now, the first one is really easy. When it's just -3, when it's just a number, that's a horizontal line. It's just like having y equals -3. Horizontal line at -3, and because this is a less than or equal to, I'm going to have a closed circle on that -1. So I'm going to go to -3, I'm going to do a horizontal line, and when I get to -1, I'm going to do a closed circle. And so I just have that line in this section of the graph. In the blue section, we are talking about things x greater than -1, and because it's greater than, I'm going to make sure I put an open circle on this one. But I'm going to do the graph of -x squared plus 4. So this is a parabola. It's been flipped vertically and moved up 4. So if you think about what that looks like in a whole graph, it's something like this. And so I'm only going to graph the part of that that would fall from -1 on. So it would be like from about right here on. So just this part. Well, to know exactly where it falls when it's at -1, I can plug in. I can say, well, what is f of -1? But I have to put an open circle on it. So in this case, it's not really f of -1, it's this function at -1. So -1 squared plus 4 would give me 3. And so if we were doing this whole graph, I would be at the point negative 1, 3. But I need to make that an open circle because I'm doing the piecewise function. So negative 1, 1, 2, 3, open circle. And then again, I know that was about right here, and my max is going to be at 4 because it was flipped and moved up 4. And so I've got this going on. If you want to know more specific points, like if I wanted to know what happens at 2, and I wish this would stop disappearing, if I want to know what happens at 2, do f of 2. So negative 2 squared plus 4 would be 0. So that can give me kind of the shape of where my parabola is going from there. And so there is my upside down parabola that's been moved up 4, and I'm only looking at the part of it that falls greater than negative 1. For example 3, we're just going to be sketching, and notice this one has 3 pieces. You have things before negative 3, things between negative 3 and positive 2, and then things to the right of positive 2. So before I start sketching, I'm going to highlight, and I have things before negative 3, so I'm going to go to negative 3 and highlight before that. And then if you only have 2 highlighters, you can leave the middle section as white. I'll do that here, and then I'm going to go to the third section. So the middle section should be white between negative 3 and 2, and then the far right section is from 2 on. So that'll be another color. Okay, on this one I'm actually going to do the middle section first because it's the easiest, because just like we did that negative 3 in the last problem, we've got a 4 here, and that's a horizontal line. So I'm going to do a horizontal line in the white section. I'm going to have an open circle on the left end and a closed circle on the right end because of these signs. So at 4, 1, 2, 3, 4, horizontal line, closed circle on the right end, open circle on the left end, and that takes care of that middle piece. The first piece, the absolute value of x plus 3, it's probably going to be in our best interest just to plot some points. We know that this is a V shape that has been moved to the left 3, or we could think about that. That's not too bad since we are meeting at negative 3. If we had that V shape moved left 3, and we were graphing that whole thing, it would be just like this right here, your absolute value graph. But I only want things that are from negative 3 back, so I only want this section of the graph right here. And I need a closed circle on that because of this sign. So I'm going to do a closed circle on the negative 3, 0, and then do a perfectly diagonal line from there. I'm just looking at that half of the V that falls in the yellow. Okay, our third section is the line 5 minus x, which you could write as negative x plus 5. It has a slope of negative 1 and a y-intercept of 5. So if you were graphing that, you would have 1, 2, 3, 4, 5, slope of negative 1, down 1 over 1. It would look something like this. But we don't want the whole thing. What we want is from 2 on. So we just want this section here. Well, to know exactly where that point is, again, I'm going to have to plug in 2. So if I plug in 2, 5 minus 2 is 3. So that point is at 2, 3 that I'm talking about right here where I start my graph. I need to put an open circle on that because of that greater than sign. So 2, 3, open circle. And I know my slope was negative 1, so I can just go down 1 over 1 from there and still get the shape right. And so there is the full graph. Okay, for example 4, we have another 3-pieced piecewise function, and again I'm going to start by highlighting my sections. I have x's before negative 1, x's between negative 1 and 1, and x's after 1. So I have 3 sections to highlight. You should probably pause and try to highlight this yourself. and I will highlight them as well. Hopefully you highlighted before -1 and then after 1 and maybe left the middle white or have it as a different color. The first section, the yellow, is going to be our 3. The middle section is very small, but it's going to have x plus 1 squared minus 2. And then the last section is going to be the line x minus 4. So again, anytime you have that plain number, that's really easy. It's just a horizontal line. So we need an open circle because of the sign, and our line is at 3. So horizontal line at 3, open circle when that ends. I'm going to save the middle one for last because it takes a little bit more work. And then I'm going to go to the blue for right now. The x minus 4, again, is a line with a slope of 1, y-intercept of -4. So we would normally go to -4 and then go up 1 over 1, and our line would look something like this. But we are using from 1 on only, so I'm only using this part of the graph. I need to know what that point is. Well, this one's a little bit easier because if we were at -4 and we want at 0, -4, and I want to know what that's at 1, my slope was 1, so I went up 1 and over 1, and that one has an x value of 1. So I don't have to like calculate too hard. I know it's at 3, so that point has to be at 1, 3 just by the way we graph lines. I need to put an open circle on that, or excuse me, at 1, -3. Need to put an open circle on that, and then use a slope of 1. So up 1 over 1, up 1 over 1. It's going to give you a nice diagonal in that blue section. And so I've completed those two sections. I'm to the middle section. Now, if you think about the middle section, this is a parabola. It's been moved left 1 and down 2. So left 1 and down 2 puts us right here, and something like this. But I only want a very small part from -1 to 1. So I need to know what some of those exact points are. The vertex landed at 1, -2 based on my shift. Excuse me, -1, -2 based on my shift. And I'm on -1 for the start. So I just need to make sure I put a closed circle there at -1, -2. Definite closed circle. I'm going to go ahead and find out what 0 and what's happening at 1. So f of 0, if I plug in 0 to that part, I have 0 plus 1 squared minus 2. So that would be a -1. So that's going to be at -1, 0, -1. And then f of 1. I plug in 1, 1 plus 1 squared minus 2. So that'll be 2. Squared is 4, minus 2 is 2. So at 1, I'm at 2, and this has a closed circle on it as well because of the way that's going. And you can see that part of the parabola taking shape, and you just kind of curve it out. Sometimes these graphs connect, other times they don't. This one doesn't connect at all. It has a jump here and a jump here. So don't be surprised if they do connect. Don't be surprised if they don't connect. Okay, for example 5, let's highlight again. So pause and see if you can highlight correctly. Okay, so check your highlighting. Because these are less than 1 and greater than or equal to 1, they should meet up at 1. One side's one color, the other side's the other color. And then we'll just start with that first one. We have a parabola that has been moved down 1, and it has a vertical stretch with this 2. But I only want the things that happened before 1. So from about right here back. I need to know what some of those points are. I need to make sure I put an open circle on 1. So I'm going to figure out what it is at 1. So f of 1, 2 times 1 squared minus 1 is 1. So at 1, 1, I'm going to put an open circle. I know at 0 it had been moved down 1, that's where the vertex is, so I know the vertex is at 0, -1. I don't have to calculate that because I know my shifts. Because it's a parabola, I know that it's going to be symmetric. So if we were here and then we hit the bottom, the next one should be at -1, 1. And I'm going to do one more. I'm going to do f of -2 and figure out where that is so I just can get the shape a little bit better. So 2 times -2 squared minus 1, that would be 2 times 4, which is 8, minus 1, which is 7. So at -2, we're at 7, and that's where that vertical stretch comes in. It grows a lot faster when you have a vertical stretch. And so my part of the graph is going to look kind of like this. We're just looking at that section of the parabola. The part in blue is going to look like your line x plus 4. So again, that was a slope of 1 and a y-intercept of 4. So if I was graphing this out, I would start with the y-intercept of 4 and then go up 1 over 1 and have a diagonal line. But because I'm only using the things to the right of 1, I only want this section. This is, again, one that's not too hard to figure out that first point, because if our slope is 1, I went up 1 and over 1, that puts me at 1, 5, and that has to be a closed circle. So 1, 5, closed circle, and then my slope is 1, so up 1 over 1. It's going to go off in this direction. Okay, for example 6, the reason that we're doing this one is because if you will look over here, this is a little bit different situation than we've done before. You have x is less than 1, x equal to 1, and x is greater than 1. I want you to color the sides of 1 just like you would before, or highlight those just like you would before. So pause and do that. Okay, so when you get done, it should look like this. In the yellow, we're going to do x squared plus 1. In the blue, we're going to do x plus 1. And truly, this might be a time for you to try this on your own because these are simple compared to some of the other stuff that we've done. So see if you can graph the left side in the yellow, the right side in the blue. We'll talk about what's happening right here in the middle when you have completed that. So pause and try that. Okay, so I'll go through this with you and see how you did. First of all, the x squared plus 1 is a parabola that's moved up 1. So you're looking at this, but you only want the part from 1 back, so kind of this section here. And you know, well, you can find that point where it is at 1. So if I plug in f of 1 just to that part, even though I'm going to have to put an open circle there, I'm going to have 1 squared plus 1, so that's 2. So at the point 1, 2, I'm going to have an open circle. I know that my vertex is at 0, 1 because I just moved the bottom of it up from 1 from 0, 0 in a shift. So I know I'm here. Again, because it's a parabola and it has to be symmetric, I know I go through the point at -1, 2. And then I'm going to do one more at -2. So f of -2 would be -2 squared plus 1. That would give me 5. So -2, 1, 2, 3, 4, 5. I can get a better shape with that one in there. And so that's how my graph looks. Then the x plus 1 is a line with a y-intercept of 1 and a slope of 1. So you'd be at 1, 1, or at 0, 1, and then up 1 over 1. We're looking at this line. But all we want is from 1 on. So we know just by graphing it that that point where that starts is at 1, 2. And due to this sign, I'm going to put an open circle on 1, 2. And it's already 1 there, which is very nice. I can just continue with my slope of 1, up 1 over 1. So I have parabola on the left, line on the right. Now that I've done both of the sides, I can look at the middle. When it says x equals 1, they're really just giving you a point. They're telling you at 1, they want a point at whatever this value is here. So this is telling me I want the point 1, 1. So 1, 1 is right here, and this is just a hole in the graph with a point that falls below it, it still passes the vertical line test. Okay, for number 7, again, I chose this one because of what's going on over here that's weird. This one we can't really highlight because it looks like absolute value of x minus 1 everywhere but 1. So it's actually on the left and the right sides of 1. It's all the same thing. At 1, it's at 1. And just like in the last problem, that's really giving me a point. It's saying that's the point 1, 1. So you can go ahead and mark that if you want. And what this means is, this top part is that there's going to be a hole at 1. So on this graph, when I'm drawing it, I'm going to put a hole where the x value is 1. So absolute value of x minus 1 is a V shape moved right 1. So my V shape that normally goes at 0, 0 is going to move right 1. And then it's perfect diagonal on each side. But at the point where x equals 1, I'm going to have a open circle. And then this point fills in above it. So this one you can't really highlight, but you have to understand what this means. It means there's a hole in this one, and this is just a point. Okay, so we're going to do number 8 on the calculator, and we are going to make sure everybody has the same window. Because these go up to 11, let's make your y max go up to 20, just so you can see it. So your x min should be negative 10, your x max 10, your y min negative 10, and your y max 20. And then what you're going to do, we're going to type these into y equals, put a parentheses, and then put your first function in, and then open up another parenthesis, and you're going to type x, then you're going to go to test, which is in blue above your math key, and so once you hit that, you'll see all the inequality symbols, and you'll scroll down to the less than sign and select it, then put in your 0 and close that parenthesis. That's telling that to only graph that before 0. Go to y2 and put in parentheses and your second line, 11 minus 4x. Open up another parenthesis. This one's going to be a little different because of the way this one is. You're going to have to put in 0, then go to test and select the less than or equal to, and then the x. You close that out and you open up another one and do x and less than or equal to from the test menu and the 2. And then you go to y3 and put in your x squared minus 3x plus 5. Open up another parenthesis and say x. Get the greater than symbol from the test menu, put down your 2, and close it out. When you hit graph, you should be able to see the piecewise function that you've created, and it should only be graphing those functions in the sections you told it to. So you should see a parabola and then a line segment, and obviously those are going to join at 11. And then down below the x-axis you will see the last parabola coming up. Now, things that you can know that your calculator is not going to show is the open and closed circles. Obviously, it's an open circle on the end of the first parabola, but it's a closed on this line, so that is going to be closed because the closed circle will fill in the open circle. And then on the other end of the line, that'll be a closed circle. And on the beginning of the parabola at the third part, that'll be an open circle. And your calculator doesn't show those unless you go to the table and look at things. But again, you guys can know that just from reading the symbols. And that concludes this lesson. Okay, after ending, we realized I've made a mistake. When I typed in my calculator, I typed in a -5 instead of a +5, which moved my parabola down. If you typed it in correctly, it should end, the last parabola should start by connecting here and look something like this. So again, you know the open and closed circles. Had it been a -5, then it would have looked like what I had originally. Since it was a +5, this actually connected and made a nice smooth graph. And that now concludes this lesson.